Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P006A, indicates a mass airflow (MAF) sensor circuit range performance problem in the Honda CR-V 2023 and onwards. This DTC is triggered when there is a discrepancy between the intake air volume measured by the MAF sensor and the assumed intake air volume calculated based on the Manifold Absolute Pressure (MAP) sensor output. The Powertrain Control Module (PCM) monitors these values, and if they fall outside a specified range, it recognizes an anomaly and stores the DTC. The MAF sensor plays a critical role in measuring the air entering the engine, ensuring that the optimal air-fuel mixture is achieved for efficient combustion. The MAP sensor, on the other hand, measures the intake manifold pressure to assist in achieving the correct engine performance. Therefore, issues with these components can affect engine performance, emissions, and fuel economy. The P006A error indicates a malfunction involving the mass airflow (MAF) sensor and its interaction with the Manifold Absolute Pressure (MAP) sensor. The MAF sensor is located in the intake air duct, typically right after the air cleaner housing. Its primary role is to measure the amount of air entering the engine to ensure correct combustion and performance. The MAP sensor is also crucial as it provides information about the pressure in the intake manifold. These components must work in harmony. If the MAF sensor's reading deviates from what the MAP sensor predicts, the PCM sees this inconsistency as a performance issue. Such discrepancies can arise due to faulty sensors, blockages in air pathways, or damaged fittings. Ensuring that these sensors and the intake air system are functioning correctly is essential for the vehicle's performance. Several underlying causes can lead to the P006A DTC. Firstly, a faulty mass airflow sensor may produce incorrect readings about the incoming air, which affects the engine's performance. Similarly, if the Manifold Absolute Pressure (MAP) sensor is malfunctioning, its incorrect signals will mislead the PCM regarding the engine's air supply needs. Blockages or restrictions in the intake air system can also contribute to this DTC, as they prevent the correct amount of air from entering the engine. These blockages could stem from damaged air ducts, debris in the intake system, or issues related to the air cleaner element. Each of these problems alters the air supply, leading to performance issues and triggering the DTC. Hence, all potential causes must be thoroughly investigated during the troubleshooting process. The symptoms associated with the P006A code can significantly impact vehicle performance and driver experience. One of the most common signs is the illumination of the check engine light, CEL, which alerts the driver to engine diagnostic issues. Furthermore, drivers may notice poor engine performance, including sluggish acceleration, reduced power, or inefficiencies in fuel consumption. Conditions such as rough idling or engine stalling may also be prevalent. This occurs as the incorrect air-fuel mixture can lead to undesirable engine operation. Lastly, abnormal behavior during vehicle operation, such as hesitation during acceleration or an unexpected increase in emissions, may also occur. Understanding these symptoms is vital for timely repairs and ensuring the vehicle operates within optimal parameters. The first troubleshooting step involves starting the engine and holding the engine speed at 3,000 RPM without any load, either in park, P, or neutral, N, until the radiator fan gets triggered. This process allows for an adequate operational condition where the engine can stabilize and enable accurate readings related to airflow and pressure values. Monitoring these values is crucial as it provides a baseline when assessing the functionality of the air intake system. After holding the RPM, allow the engine to idle, enabling the PCM to recheck the data after the variable condition. This step helps in identifying if the DTC P006A has been reset due to the conditions being met, or if it remains present. Any abnormalities observed during this process should lead to further inspection of the involved components. In this step, the technician should take the vehicle for a test drive, maintaining speeds that correlate with the previously recorded onboard snapshot parameters. It is essential to monitor the engine speed, vehicle speed, map sensor voltage, and throttle position (TP) sensor during this phase. Each parameter plays a critical role in informing the PCM about the operational state of the vehicle and its engine components. By comparing these values against the data stored during the engine test at a controlled RPM, discrepancies can lead to further diagnostics. After driving, checking the onboard diagnostics OBD status can help in determining if DTC P006A reappears. The interaction among these readings allows for a comprehensive understanding of component performance, leading to targeted repairs. The third troubleshooting step involves inspecting the positive crankcase ventilation (PCV) system, including the PCV valve, PCV hose, and the purge line. Any physical damage to these components can inhibit the function of the intake air system. The PCV valve regulates gases that are released from the crankcase, which can affect the mixture of air and fuel entering the combustion chamber. Checking for any physical damage, restrictions, or blockages at these connections is crucial, as it can lead to improper readings from the MAF and MAP sensors. If any parts show signs of wear or obstruction, they should be addressed as part of the repair process. Confirming normal conditions at these connections is essential to rule out issues before moving on to the next steps in troubleshooting. For this step, it is essential to visually inspect the intake air duct and air cleaner housing for any blockages or physical damage. This inspection is important, as any debris or obstruction in the air path can directly influence the accuracy of the MAF readings. Blocked or damaged components could disrupt the airflow, leading to performance issues reflected in the DTC P006A settings. Validating connections in the intake system will aid in confirming whether air can flow freely into the engine. Normal conditions dictate that all components are intact and without blockage. Finding any issues in this step may indicate broader problems within the intake air system, necessitating repairs or replacements as needed. The next step involves functional testing of the MAF sensor while the engine is turned off. The Honda Diagnostic System, HDS, should be used to confirm that the MAF sensor reading is approximately 0.2 grams per second, GSS. This measurement reflects the sensor's ability to detect the airflow into the intake system accurately. A reading significantly different from this value can indicate that the MAF sensor, or possibly the intake air temperature, IAT, sensor positioned alongside it is malfunctioning. This step is crucial because a faulty MAF sensor can lead the engine to receive incorrect air-fuel mixture information, resulting in performance issues. If the reading deviates from expected values, further investigation into the MAF sensor and its connections is required. The final functional inspection focuses on the MAF sensor while the engine is running. The process involves varying the engine speed between 2,000 RPM and 3,000 RPM and monitoring the HDS for the MAF sensor readings. A functioning MAF sensor should show a proportional relationship with the engine speed. As the RPM increases, so should the MAF sensor reading. This confirms the operational integrity of the MAF sensor and the air delivery system. If readings do not reflect expected changes, this signals that either the MAF sensor or the IAT sensor could still be faulty. Addressing these issues promptly ensures the vehicle performs efficiently and effectively, maintaining optimal fuel economy and emission standards. If abnormalities are detected in this final check, repair or replacement of the sensor might be necessary to resolve the DTC P006A. After completing the necessary repairs based on the diagnosis of P006A, it is critical to perform a final verification. This involves clearing the DTC codes from the system using the HDS and subsequently taking the vehicle for a test drive. During the test drive, monitor the engine performance closely, ensuring that any previous symptoms have been resolved and that no DTCs reappear. Assessing the vehicle under various conditions, start, stop, acceleration, and idle, will provide confidence in the efficacy of the repairs performed. If the vehicle operates smoothly without triggering the check engine light, it indicates successful completion of the diagnostic and repair process. Proper verification not only ensures reliability, but also establishes peace of mind for the vehicle owner. Preventative maintenance is essential in ensuring the optimal performance of the intake system and avoiding issues related to DTC P006A. Regular inspections of the air intake system components should be conducted to identify any blockages, damage, or wear. Additionally, replacing the MAF sensor, as recommended by the manufacturer, can prevent potential malfunctions. Keeping the air filters clean and replacing them when necessary contributes significantly to engine performance and efficiency. Regular maintenance not only prolongs component life, but also enhances overall vehicle performance. Establishing a routine maintenance schedule will help in detecting early signs of wear or malfunction, ensuring the longevity and efficient operation of the vehicle. In conclusion, the DTC P006A signifies a critical performance issue related to the mass airflow sensor and its interaction with the MAP sensor within the Honda CR-V 2023 Plus. Accurate diagnosis and the subsequent troubleshooting steps are paramount to identifying the root cause of the problem. By carefully inspecting relevant components, such as the MAF sensor, and ensuring the integrity of the intake air system, technicians can effectively resolve this DTC. It is essential to follow the troubleshooting steps in a methodical manner, ensuring that all possible causes are examined. Regular preventive maintenance will contribute to minimizing future issues and will significantly enhance engine performance and efficiency. Doing so will ultimately lead to an improved driving experience and reduced operational costs for the vehicle owner. Please like and subscribe to the channel. See you next time.